Hello everyone, welcome to my engineering channel. My name is Thomas, and in this short Matlab tutorial, I'm going to show you how to plot a sinusoid in the spatial domain. Well, before we go through the actual code, as usually, let's have a look at the final result. So I created a simple example. If you already watched my previous video on how to plot a sinusoid in the time domain, in this video, I'm going to show the difference between the two domains. And also I will present two windowing techniques, basically how to crop your sinusoid signal to a specific distance range. Well, let's create this figure again, step by step. Okay, I closed it, and now let's create a new empty figure, and let's position it here. Okay, before we start, we should define our sinusoid parameters. So these are slightly different to the time domain parameters. So instead of having a frequency in hertz, we have wavelength. And I set this one to be 2 meters. In terms of the amplitude, these are 15 millimeters. And the initial phase is 0 radians. To define the distance array, we need to define the sampling frequency. And I set this one to be 1000 samples per meter. And here I'm calculating a distance array. I'm defining it from 0 to 20 meters. And here I'm calculating so-called spatial frequency. So it's not the angular frequency as in the time domain. The difference is that I'm dividing 2 pi, the product of 2 pi by the wavelength of the signal. So let's move on. And here I'm going to present only one technique, how to plot the actual sinusoid. So I'm using the classic Matlab sine function, and the argument of this function in the spatial domain is slightly different to the time domain. So I'm multiplying the spatial frequency by the distance array, and I'm adding the initial phase. So this is slightly different. In the time domain, we had multiplication of product of the angular frequency and time array. Okay, and again, the whole sine function is multiplied by the amplitude. So I'm plotting this signal against distance. So let's see how it looks like. And this is it. So this is our first sinusoid in the spatial domain with the wavelength 2 meters. And okay, let's move on. I'm going to show you how to crop this sinusoid to a specific distance range. So let's assume that we have the starting distance 6 meters and the ending distance 14 meters. And between these 2 points, we would like to plot our sinusoid. So how to do it? Well, again, similar to the technique presented already for the time domain, I am basically setting the signal values outside of this range, outside of this window, to 0 value. You have to calculate the proper index from to which it should be set to 0, and this can be done by simple multiplication of the distance and sampling frequency. Okay, so let's have a look how it looks like. So yeah, so this is a sinusoid plotted only for specific distance from 6 to 14 meters. Okay, let's move on. I'm going to show you one more technique, how to do the same, how to come up to the same result. But here I'm going to use another technique using concatenating function, okay? So what I have to do is I have to derive the first distance array, which is from 0 to 6. And I will create also signal for this distance array. And I will multiply it by 0 because I would like to have these values 0, okay? Then I will calculate the actual non-cropped or non-windowed sinusoid. And again, this will be of length 8 meters. And I'm just simply calculating the actual signal. And finally, there is signal distance from 0 to 6 meters. And I create or calculate also the corresponding signal, which is again set or multiplied by 0 to get 0 signal. Then what I have to do is to resample the distance because I simply calculate this from 0 always, which is much easier than always to calculate the starting point. I could do it also as well. Yeah, that's also one more technique, but I find it a little bit easier. And then I just resample the final distance to the actual distance I would like to have. And then this is the concatenating signals technique here. So basically I'm taking these signals calculated before and I'm just putting them together in one single array. Okay, just be careful that you have to start with the second index for the second and third signal because these are defined from 0 value. Okay, so I'm plotting this and let's see what's the result. So we can see that there is perfect match between these two techniques. So let's just add legend. Okay, and we can have a look at, let's zoom in a little bit here. How is this detail? Is it starting from 6? Yeah, exactly. Both techniques. So this is it. This is a simple trick or tip how to plot sinusoid in the spatial domain. Hope you like this video. Thank you for watching.